Hello, ladies and gentlemen, and we need to finish off Lesson 5. We spent a great deal of time talking about the beginning of this page and got into some good arguments about it, and I think that was really well covered in class. I think it's just some of the examples I need to finish off. I think I'm going to go to this one. I think that's where I was kind of left off. So there's two ways I'm going to think about doing this. The first one gives me a hint. It says to determine a common denominator first. So now it looks like the other questions that we've done, all we have to do is use our theorem. I'm going to divide by the largest power of the limiting variable in the denominator. And that's going to leave us with if we go and allow the limit to start doing its thing, this will get larger and larger and larger. It'll then be taken to the power of 3, which will get larger even faster. So 1 divided by a bigger and bigger number means that this whole thing is going to go to 0, and we get a final answer of 6. Another way to do this exact same question is to use your limit properties. So I'm going to take my limit of a sum, and I'm going to change it to the sum of the limits. So I'm going to take a limit of a sum and I'm going to change it to the sum of the limits. The limit of a constant, as x approaches negative infinity, 6 doesn't care about the limit, it's just going to be 6. And this one, as x gets larger and larger and larger negatively, it's going to be cubed, in which case then it's going to be 1 over a larger and larger number, so that whole thing is going to go to 0, which is going to leave us with a simple answer of 6. Both work, both are great. Okay, moving on to the next one. So what I have here is I'm going to take this and I'm going to divide top and bottom by the largest limiting variable in the denominator. What that's going to leave me with is let's let the limit do its thing. Now watch what happens here. This one and this one straightforward. As x gets larger and larger and larger, 8 over a larger number is going to go to 0. That one's going to go to 0 for the exact same reason. Something interesting here though is this one's going to go to infinity. It's going to be squared. It's going to be even larger infinity. Times 5, it's going to be an even larger infinity. And we're going to be subtracting a smaller infinity. Okay, I think that we can easily say that this is approaching infinity faster than this one. So this one will slow it down definitely, but it's still going to be moving towards infinity. And so our final answer for this one is actually, and that is equal to infinity. So infinity divided by 3 is simply infinity. And once again, you got to think of infinity as a direction. So if I'm going east, and I slow myself down by dividing my speed by 3, by taking my speed and making it 3 times slower, I'm still going east. Not as quickly, but I'm still going east. And how did we determine that there was actually infinity up here? Because look, both of these x values are going towards infinity at the same speed. But then this x values is squared, so it's going even faster. And then it's times 5, it's going even faster. This one's only times 2. It's nowhere near as fast as this one's going. And so as we think about this, as this one's getting bigger and bigger and bigger and bigger, this one's getting bigger and bigger and bigger slower. So think about it. You've got, maybe I can sort of show this with a picture. We've got that size and that size being taken away, but this one gets bigger faster than that one. Now they both got bigger, but this one's getting bigger faster than this one. You're always going to have a little bit more left over. And so that little bit more is still going in the direction of infinity. And so our final answer is infinity on top. So that might hurt your head a little bit, but that's a good hurt. Think about that for a little bit. Let's go on to example F. So I'm going to take this one, and I'm going to take the limit as x approaches infinity of 3 x to the 3 divided by x to the 4. minus 5x over x to the 4 over top of 7 x to the 3 over x to the 4 plus 4x to the 4 over x to the 4. That's going to leave us with, now I don't like where that limit is. That should have been down here more. And encompass the whole thing, right? The whole thing's being taken to the limit. So this is going to give us the limit as x approaches infinity of 3 over x minus 5 over x3 over top of 7 over x plus 4. This gets larger and larger and larger, so this entire fraction becomes closer to 0. Same argument here, same argument here. What we get left with is 0 subtract 0 over top of 0 plus 4, and you're left with 0 over 4, which quite simply is 0. And that's a good answer. We're fine with that answer. Okay, so that's that sheet. Let's look at what's over here now. Looks like I've got a couple more. I think I'm going to pause the video and do the next ones just in case I goof up. I still got this video and I just have to redo it from G.